Okay. Dear colleagues, distinguished guests, ladies and gentlemen, dear Maria, I want to welcome you and the others. On behalf of Mr. Tsiodras, we welcome you in this today event. Unfortunately, there are some very urgent issues for the upcoming plenary Strasbourg next week, and Mr. Tsiodras has to discuss with some MEPs. These MEPs live today for Brussels. He will be here, but he has to discuss with them. And there are some other issues for the chemical omnibus that we are discussing ahead of the Santos Meeting on Tuesday. So she's very, very busy now. I has to be with him, but someone has to be here. So we prefer myself to be here, and after, if possible, he will join us even at the end of the closure. So, on behalf of him, it's a great pleasure to welcome you today to this discussion on PFAS, organized together with the European Chemical Society. I remember that the last event that organized with the European Chemical Society, it was just 3 years before, with hosted by Maria Spiraki. We organized it, and we are very happy to see some same persons in this today event. So, as many of you have noticed, the European Parliament is hosting several PFAS-related events this week. This shows how central and sensitive this debate has become for Europe. Therefore, let me start with a broader point. Europe today stands at a crossroad. Our industrial model is under pressure from high energy costs, stronger global competition, and increasingly fragile supply chains. At the same time, European citizens rightly expect a high level of protection for health and the environment. The PFAS debate perfectly illustrates the need to reconcile these two objectives through a balanced and science-based approach. At this point, let me be clear. Where chemicals pose serious risks, they must be addressed decisively. Protecting citizens and the ecosystem is not negotiable. And this is our principle, this is our main line, and during the current negotiations on the chemical omnibus. The protection of the European citizen is without negotiation. It's on the first row. But a blanket ban is not a credible and workable solution. As you know, PFAS are not a single substance, but a large and diverse group of chemicals used in many strategic sectors of the European economy, like aerospace, semiconductors, electronics, medical devices, batteries, and renewable energy systems. In many of these applications, you know very well that PFAS provide performance characteristics that it's really extremely difficult to replicate. And therefore, our objective must be pragmatic. Replace PFAS where viable alternatives exist, and manage risk responsibly where they do not be replaced. For this, regulatory decisions must rely on two key elements. The first is the availability of safe and scalable alternatives, and the second should be a robust risk-based assessment that considers exposure and real-world use conditions, not paperwork, real-world use conditions. It's very, very important to understand it. And we'll try to convey this message also in the current negotiations for omnibus, that we have to negotiate, we have to discuss on something that it will be based in the real life, not on a paper. So we consider that only combining these elements can regulation remain proportionate, legally robust, and economically sustainable. This is particularly important for strategic sectors where alternatives are not yet available. Restricting PFAS without viable substitutes could lead to production relocating outside Europe, and therefore little environment will having little environmental benefits. And I'm pretty sure that is something no one wants to see in Europe, to allow the industry to relocate. Substitutions will consider that substitutions work only when alternatives are safe, technically viable, and economically competitive. And of course, this criteria to be aligned with the current REACH regulation. And we support this criteria for the alternatives in the current discussions in the chemical omnibus when it comes to the cosmetics. And this requires strong investment in research and innovation. What does it mean? It means that in order to find the right alternatives, the suitable alternatives, we have to invest, we have to strongly invest in research and innovation. And this point brings me to a broader point about our regulatory framework. Simplification is not about lowering standards as many people believe and they advocate for this. Simplification is about creating the conditions that allow innovation to flourish. Nothing less, nothing more. This is also the objective of the Omnibus 6 initiative, where our focus, the focus of the co-rapporteurs, is to deliver smarter regulation that preserves safety without strengthening Europe's competitiveness. So, let me emphasize one point which is just very, very clear. Simplification is not deregulation. Competitiveness is not the opposite of safety. They can go hand in hand, they can go together. But what we need a careful, sector-specific approach, recognizing both the risks associated with PFAS and their continued role in critical industries. Europe's strength has always been its ability to combine high standards with industrial leadership. So, our objective must be to protect citizens while ensuring that Europe retains the technologies, industries, and expertise that we needed for the future. Finally, effective policy making requires partnerships. We need partnerships with you. Scientific expertise, industrial data, and real-world experience are essential to designing regulation that will work in practice. Your engagement, the engagement of the stakeholders, is therefore not lobbying in the narrow sense. Your contribution should be essential in order to make a better policy, to make the policy making to be much more effective. We consider that Europe's future chemicals framework must be built on trust. It means trust in science, trust in institutions, and trust that competitiveness and sustainability can advance together. Saying that, I will also, again, thank you very much for coming here. We welcome all of you in the House, and we look forward to this very fruitful discussions today.
Thank you very much. Let me introduce myself. I'm Angela Agostiano. I am the president of UCAMS, and on behalf of UCAMS, I warmly welcome you, all the people that are present to this workshop on relevant topics that is related not only to science but to the life of every citizen. So let me thank, before to start, our host, It was supposed to be here, but the institutional other problem. Dimitri Tsiadas.
Sorry, I apologize that I forgot to let you know that I am Christos Vasilakos. I'm the head of Mr. Tsiadas' office, and I am the person who is involved in the chemical debate as the chemist.
So, I thank you very much to be here, and I think that your presence in these workshops is reassuring us that the connection between science and policy decision are strong, and the legislative decisions are very much related on grounded science decision. So, before I would like to thank, of course, Floris Routis, who will be in charge of the scientific part of this workshop. Many thanks, Floris. And Ninetta Hache, the General Secretary of UCAMS, and her team, to have, because they organized this workshop. Many thanks to you. And so, before to start, I would like briefly give you some information on UCAMS. What is UCAMS, what it does, UCAMS, and why UCAMS is here today. Okay, UCAMS is an organization that is a transnational organization, of course, because it's made by, represents more than 145,000 component members that they come from 48 organizations, scientific and not only scientific organizations in Europe, coming from 35 European countries. So it's quite a large network that, from my point of view, is a live representation of what means science without border. Because we strongly believe that this year that we cross by are very difficult, and several decisions are decisions that will invest the life of several people. And this decision cannot be taken alive in solitude. No? We need connection, we need interaction, and so to have an organization who put together the best minds in research in Europe is something that help, I think, generally to have decisions regarding energy, environment, and development can be really shared between several countries, beside the difference that politically are related to these different countries. So what UCAMS does? Of course, UCAMS does several things. One of the most relevant is, of course, to organize congresses that are, the aim, the goal of these congresses is put together scientists from different disciplines and from different countries that are able to meet each other and to share their knowledge and to try to improve to solve, to give a solution to the several problems that arise during this time. And of course, this Congress help to have a network, not only between scientists, all scientists, I would say, but above all with young chemistry scientists. The network that we have, the Young Chemistry Network, is very much important because the young researcher, and not only researcher in academy, but also in industry and in laboratory, can meet together, join together, find opportunities, but above all, they work together, and this is very important for the future, I think, not only of our organization, but of Europe in general. And of course, we try to support our members with a lot of awards. They recognize excellence, but they recognize also young people that are in the early times of their career, to support them to stay in the university, to continue to work on science, also if they work in the industry. And of course, the policy, the relationship with policy is one of our important goals, because we really, we really believe that the connection between policy and the decision they will take and the scientists who will work in several places of the world in chemistry will help generally to have a more global idea of what is in front of us and to look forward. And of course, another of our goals is the diffusion of the chemistry culture through our socials and also through our magazine, that very much are a connection also with the decision in the Parliament and from the Commission. So at the end, I will again thank you, and before to give the floor to Floris, who is in charge of the scientific part of this meeting, I think that this meeting is very important, and we have to continue to have this meeting, look forward to make this contact stronger and stronger in the future, because we know that there is no future without this connection between science and policy. Thank you very much again, and please, Floris, the floor is yours.
Thank you, Angela. Good afternoon, everyone. Welcome to this workshop. I'm very pleased to see so many of you joining us here today on this event on PFAS, a topic that is of course of great relevance and concern to all of us. My name is Floris. I'm a past president of the European Chemical Society of UChemS, and chairing this workshop is actually one of the last official activities in that role. But I'm particularly glad to do so because this is a subject that is very close to my heart, and one also that has a significant impact on society. As a chemist and a representative of the chemistry community, I'm an organic chemistry professor at Radboud University in Nijmegen in the Netherlands. I'm truly proud of what chemists and the chemical industry have achieved. Much of the comfort and convenience that surrounds us today, from food and medicines to comfortable clothing and advanced materials used in everyday technologies, they would not exist without scientific discoveries in chemistry and the innovations of the chemical industry. Think, for example, of smartphones and other electronic devices. The level of well-being we enjoy today is deeply connected to progress in chemical science and to progress in science in general. However, as with many technological advances, there can also be a downside. Products that initially appear to offer clear advantages over existing solutions may later reveal adverse effects that were not known at the time of their introduction, effects that sometimes only become apparent after many years of widespread use. These may include the generation of waste that turns out to be harmful, the accumulation of persistent substances in the environment, long-term health effects upon prolonged exposure, or combinations of those factors. I think it's inevitable that these things happen and come along with innovations in general. In the Netherlands, we have a term for this: voortschrijdend inzicht. It is something that does not translate easily into English, but it roughly means that our understanding evolves over time and new insights emerge. In other words, at a certain point it becomes clear that change is necessary and that new regulations and new approaches are required. This is exactly the situation we are facing with PFAS today. New legislation is currently being developed, and it is important that this process is guided by sound knowledge and careful consideration. The European Chemical Society has organized this workshop to contribute to that decision-making process. As always, UChemS approaches such discussions not by just prescribing specific policy choices, but by bringing together experts from different relevant fields to provide unbiased, science-based information. The aim is to help answer key questions and thereby support policymakers and politicians in making well-informed decisions. This philosophy is also reflected in the format of today's workshop. We will begin with the presentations from the European Chemicals Agency, ECHA, by Maria Spiraki, who will provide an overview of the decision-making process. This will be followed by 4 lectures from experts who will present different perspectives on PFAS, from scientific and environmental viewpoints to industrial and legal considerations. These lectures will address how PFAS affect the environment, how the search for alternatives is progressing, and what challenges and opportunities exist. They will also explore what is feasible, what may not be, and what efforts are required to move forward. Each lecture will last 10 minutes and is followed by a short discussion. And later in the program, after an update from the European Commission by Dennis Montet, we will conclude with a Q&A session with the speakers, in which everyone here will be invited to participate. But with that, I hope you will find this workshop both informative and useful, and I look forward to lively and constructive discussions. That means that we can also start with the workshop, and I would like to give the word to Mariam Spiranki to talk about the decision-making process.
It is very kind of you, ladies and gentlemen. Thank you very much for having me here, and I would like to thank especially EU CAMS for organizing this workshop, and also my former colleague Dimitris Chioros, who is not present here, and his assistants Christos Vasilakos, for hosting this timely event. And allow me first of all to introduce myself. My name is Maria Spiraki. I was serving this house for 10 years with 2 mandates. I am a chemist by education, and I hold a Master of Science in Energy, and now I am representing the European Parliament in the Management Board of European Chemical Agency. I have been appointed by the Parliament last year, by the end of last year. Allow me also to clarify that the information, the public information coming from ECHA's website is in my speech as well, and all other arguments and points of view are strictly personal. It is important to clarify this. And of course, I will not participate in the Q&A session because, as you know, we in ECHA Management Board, we are a governmental board and not a scientific committee, so we are not entitled to exchange views publicly. As you all have been aware, this week the European Chemical Agency Risk Assessment Committee, the RAC Committee, has concluded its evaluation for the universal restriction proposal on all PER and polyfluoroalkyl substances, its PFAS. Its opinion is the first part of ECHA's 2-committee scientific evaluation of the proposal. RAC, the Risk Assessment Committee, has adopted its opinion drawing on an extensive and independent evaluation of PFAS, hazard, volumes, emission risks, and the likely effectiveness of a restriction, as well as its particularly including impossibility. Since January 2023, ECHA has been evaluating a wide-ranging restriction proposal prepared by the national authorities of Denmark, Germany, the Netherlands, Norway, and Sweden. This proposal aims to apply a class-based restriction to over 10,000 PFAS, covering many key sectors of the economy. ECHA has 2 scientific committees. It is the Committee for Risk Assessment. It is also the Committee for Socio-Economic Analysis, the SEAC Committee, and have been reviewing this dossier in depth. RAC evaluates the risk to human health and the environment, of course, resulting from the manufacture, placing on the market, and use of chemicals, while the Socio-Economic Analysis Committee, SEAC, evaluates the socio-economic impacts of a restriction, taking into account the availability of alternatives. The adapted RAC opinion will be published soon, so we'll have the details, providing full details of the opinion content. SEAC is expected to agree its draft opinion next week. This draft opinion will be subject to a 60-day consultation, which is very, very important, inviting all of you detailed evidence from all stakeholders on health, on environmental and innovation impacts, as well as availability and viability of alternatives. SEAC is expected to adopt its final opinion by the end of this year, by the end of 2026. This adoption will conclude ECHA Committee's scientific evaluation of the proposed restriction, and the opinions are formally submitted to the Commission. The European Commission, based on the 2 opinions, will propose a restriction for discussion and vote in the REACH Committee, composed, as you know, by EU Member States representatives. This will maybe enable the European Commission to draft the relevant piece of legislation to be discussed in the EU by the Member States and the Parliament in 2027, but it remains to be seen. It is always a matter of the decision-making in each committee. As we all are familiar PFAS are a vast family of synthetic chemicals known for their remarkable resistance to heat, to water, to oil, and chemical degradation. These properties have underpinned decades of industrial use across countless sectors, from electronics and semiconductors to medical devices, textiles, packaging, and firefighting forms. But that very durability has a very, very dark side. PFAS are exceptionally persistent in the environment and can accumulate in water, soil, wildfire, and humans, earning them the label of forever chemicals. Their persistence means that once released, they remain in ecosystems for long periods, with science-based implications for human health, including links to immune system effects, reproductive health, developmental issues, and chronic disease. It is precisely because of these concerns that the European Union, has embarked on one of the broadest regulatory initiatives in chemical history, and I would like to highlight. Now, we have the regulatory status and the PFAS restriction process. Under existing EU legislation, several PFAS subgroups have already been restricted. For example, I would like to mention PFOS. This has been restricted for more than a decade under the EU's persistent organic pollutants regulation, and PFOA, which has been banned in 2022. More recently, other long-chain perfluorinated carboxylic acids and related compounds have been under EU restrictions. So, to my opinion, the main challenges is how can we balance public health protection with innovation? At its core, this process reflects a profound regulatory challenge. On the one hand, PFAS restriction aim to reduce long-term exposures, protect ecosystems, and prevent further contamination of water, food, and people. The precautionary approach here is both scientifically grounded and socially responsible, acting before irreversible damage occurs, and it is important for all of us to prevent. It will take long to present a lot of cases related to PFAS contamination. Allow me just to mention one of them, taking place here in Belgium, leading to a lawsuit of 1,400 local residents against the chemical company due to PFAS contamination of soil around their residences. Yet, on the other hand, many PFAS technologies are leaping embedded in performance-critical applications. Industries such as electronics manufacturing, energy technologies, aerospace, or advanced medical devices rely on PFAS for functions that, according to their assessment, that are not easily replaced. Transitioning away from PFAS without careful planning could disrupt global supply chains, slow innovation, and incur significant compliance costs, which is also a very, very important issue. In this regard, I would like to highlight the outcome of a study under the title Per and Polyfluoroalkyl substances, PFAS, and their role, presented last February in the committee of this House. Following the statement of Christian Eller, who is one of the most senior members in this House, the key message of the study is that in many high-performance and safety-critical applications, substitutes are currently either technically unfeasible, economically non-viable, and not yet market-ready. Transition periods and viable alternatives are essential to safeguard our competitiveness, EU competitiveness, and our transition to a green and digital economy with no backtracking. This is why the regulatory debate is not simply about prohibition. It is about transformation, creating a predictable, scientifically anchored regulatory framework that protects health and the environment while fostering innovation. Speaking for innovation, allow me to mention very briefly some concrete examples which I think that it is important to follow. I am very optimistic that in response to regulatory pressure and market demand, a broad spectrum of PFAS-free materials and technologies are already emerging. For example, PFAS-free coating for textiles and packages, silicone and denier-based alternatives. Hydrophilic PFAS-free coating for medical devices, and also bio-based and nanostructured materials that are used for covering various devices. These examples demonstrate something crucial. Innovation is not being stalled by regulation. It is being accelerated by it. Regulatory clarity and long-term direction create incentives for investment in sustainable materials, alternative manufacturing processes, and entirely new product designs. The PFAS restriction proposal represents a defining moment in European chemical policy. If implemented effectively, it could set a global precedent for managing persistent substances at scale, moving beyond the incremental management of individual chemicals. Yet, success will require collaboration among regulators, scientists, industry stakeholders, and civil society. It will require transparency about where PFAS are still essential. And please allow me to say that it is important for the industry not to overuse the argument of essential use. We also need robust evaluation for subsidies, transition timelines that balance agency with visibility, which is also important, and research support for innovation where alternatives are still lacking. In this regard, the 2026 consultation on SEAC, the Socio-Economic Assessment Committee, draft opinion will be a key milestone, an opportunity for industries to present evidence on substitution efforts, timelines for transition, and socio-economic impacts. To my conclusion, the PFAS reduction effort is not merely a regulatory exercise. It is a strategic and societal effort to protect public health, to heal environments burdened by persistent contamination, and to steer industry towards safer, sustainable innovation. We face a challenging path ahead, but if we commit to science-based policy, constructive dialogue, and forward-looking research, we can transform this challenge into an opportunity to lead in sustainable chemicals by design, to protect human health and ecosystem, and to ensure that Europe's industry remain at the forefront of technological innovation. Thank you very much for your time.
Maria, for sharing those insights with us. That's also paves the way for going to the first scientific presentation, which will be held by Professor Martin Scheringer, who is a professor of environmental chemistry at the ETH in Zurich, in Switzerland. Martin, please go.
Thank you very much to our host for having this event, and to Angela and Florence for the invitation to speak. Good afternoon, everybody. I will talk about the steps on the way from PFAS and their many uses into alternatives that can work without fluorine. So first, why do we use PFAS? And of course the answer is because they're very useful. And I will just briefly show the map of the landscape of PFAS, and there are four main groups, and this is based on the paper given at the bottom of the slide by Erik et al., and that's a very useful paper to get an orientation of the overall situation and picture. So the first group is shown here. These are carboxylic acids and ether acids that are mostly used, were used, or have been used as processing aids in the manufacture of fluoropolymers and also in other applications. And they were also the chemicals that cause a lot of contamination around these fluoropolymer manufacture sites. Next, please. Then second, there is plastics such as, meaning fluoropolymers such as Teflon, and they are made in many cases with the use of the acids shown on the left. And again, there was has been a lot of contamination from exactly these processes because they are not without emissions. And that's one of the key questions. Please. That's one of the key questions. How can we lower or reduce the emissions from these production? The third group is at the bottom. That is an example of chemicals, PFAS, that perhaps were used. Often it's hard to say, is it were or is it still is, because we don't know exactly which ones are being used. That's why we're struggling here with what's current and what is already past. So this is an example. This is a side chain fluorinated polymer, which is an example of impregnation agents. And the chemicals used to make these side chain fluorinated polymers were also used in other combinations, other chemistries, for firefighting foams and other impregnation agents. Important, these side chain fluorinated polymers are very different from actual fluoropolymers, where the backbone is fluorinated, so very different types of materials. Next, please. And then the last big group is fluorinated gases used as heat carriers in refrigeration and air conditioning and heat pumps. And the heat carriers and the fluoropolymers are the groups that have the greatest tonnage, the greatest production volume of all PFAS. And now this slide shows the huge diversity in chemistry and in functions. But it's also important to see that all of them are still unified by one characteristic, and that is the enormous stability of the fluorinated chain. The fluorinated chain does not degrade in the environment, so all emissions of PFAS lead to a greater and greater pool of fluorinated chains in the environment. And that leads to higher and higher exposure of the environment and of humans. Next, please. Now, why are we concerned? Of course, we are concerned because PFAS also do damage. They don't have strong acute toxicity, but they have a pronounced chronic toxicity. They contribute to cancer, kidney cancer, testicular cancer. They damage the liver, damage the kidneys, damage the function of the thyroid gland. They reduce the sperm count in men. They may cause miscarriages in women. They reduce the immune response after vaccinations, and they disturb the lipid metabolism. So many effects like a shotgun on the body that are caused by PFAS. And because some of them have a very long residence time in the human body, they do have the time to cause these chronic effects in humans. That is a very unfortunate and difficult situation. And again, all of this is even made worse because of the persistence, because persistence means that the exposure is higher and longer in time and more widespread. So higher exposure means also then more effects in humans. Next, please. Now, a big obstacle in the discussion, I think, is what I would call PFAS fallacy. By this I mean that what's given here, the statement that PFAS have unique properties, which is true. There's no material that is like PFAS, and they have boosted all or many of the uses to a level of performance that is very high. And because of that, they are indispensable or irreplaceable. And that is the fallacy, because, next please, because if we manage to find and piece together different materials that can fulfill certain aspects of the function of a certain PFAS and piece them together like pieces of a puzzle, we often are able to put together something that offers the same function and service. So if a range of different non-PFAS materials are combined, they offer a sufficiently broad spectrum of properties and a sufficiently high level of performance so that they can replace PFAS in most or many of the uses. Not all, but in many of the uses. So that's a very important point to make here, that we should not be blinded by this, by the strong performance of PFAS as wonderful materials, which they are, because we can find ways around and piece together solutions. Next, please. What do they look like, these solutions? And here are just some quick examples, and in the downturn we'll go over that in more detail. The first one is here about surface treatment, and there is a low-tech and a high-tech version on that slide. First, the low-tech is for baking paper, because I've learned from paper makers, they can make paper by grinding the wood in paper mill in a way that the fibers of the paper stick together more tightly, and no pigmentation agent is needed, and still paper is grease repellent. That's a low-tech solution. Next, please. The high-tech solution is the outcome of materials research, and here's a review paper from which I just take the quote at the bottom, saying, the first section of this review describes how to design and obtain fluorine-free hydrocarbon surfactants as viable replacements for PFAS. It is shown that highly branched hydrocarbon surfactants can generate low surface energies comparable to those of fluorocarbons. Please. Then firefighting foams, which is an area where we would say that is a pragmatic application of PFAS, because that needs something that doesn't burn, that's inflammable, that spreads out, it forms a thin layer on top of the burning fuel and cuts off the fuel from the oxygen in the air. So that kind of seems to call for PFAS. But stunningly, 3M, the company who has made these fluorine-based foams, were also able to make fluorine-free foams, even 20 years ago at the same time. The same company shows how powerful chemistry actually is. So innovation is there and has been there all the time, and it shows it's possible to do the same thing with a totally different chemistry. And these foams have the performance that's required and have been used at airports for more than 15 years. Then the big group of the fluorinated gases used in all kinds of heating and cooling devices. Here we worked together with a team of heating and cooling experts, and we went in this kind of lengthy paper shown here through a lot of applications of these gases, and we found that in all cases there are non-fluorinated alternatives that do the job as good or even better, than the fluorinated gases. Better meaning also more energy efficient. And many of these alternatives have been on the market for long. They're not even new, and not much new research is really needed to develop them. So there's no technical barrier in that area. Then the energy sector and the energy transition. It's often said that PFAS are important for the energy transition, and when we look back to how the components were made of the energy transition, then we see that in many cases PFAS were used as essential or important components. But we see now also more innovation and development that there are more and more versions of the same technologies on the market that work without PFAS. Here it's the backsheets of solar panels, which is an important layer of a polymer at the back of the panels, and there are companies who have been on the market with PFAS-free backsheets for long, and they're totally performing and good enough. Next, batteries. There's one example here. It's a Swiss company called L'Étranger who makes and has on the market PFAS-free batteries, scalable. Next. And also the other components of energy generation or energy use, fuel cells and electrolyzers, also those ones are now PFAS-free, PFAS-free models on the market. So again, a lot of innovation taking place and making steps into the market. And semiconductor industry was also mentioned, a very important industry. It's a bit small to read, but this is from the website of Transcene, a company in the US, and they have in the small print a list of the many chemicals that are required for the manufacture of semiconductors. And next please, they have been able to make many of these chemicals without PFAS. So it says, Transcene company eliminates its use of PFAS and saves money. And of course still offers all these chemicals to the actual manufacturers of the semiconductors with the required performance. So in conclusion, I would say, or I think it's important to see that the persistence of the chemicals, or the fluorinated part of the chemicals, is the main cause of the PFAS problem, because it makes exposure longer, higher and more widespread, and that causes also more effects. Effects caused by chronic toxicity. And the sad thing is, and that's also what many of the people affected by PFAS contamination in many European countries are now suffering from, there are diseases that develop over years and decades. And now we see the occurrence of these diseases, and that is really, really saddening and serious. And then therefore we need to advance innovation and development and marketing of alternatives, because PFAS are not per se irreplaceable. And last piece. So that's captured by the heading of this editorial that I published in Science a while ago, Innovate Beyond PFAS. Avoid using PFAS wherever possible. That is the point of the section proposal, wherever possible, not everywhere. Many alternatives already exist, and where they're still missing, we need to support research and development and innovation. Thank you.
Thank you very much, Martin. There's a few minutes for questions. Wolfgang.
Yeah, thank you very much for this very, how to say, optimistic view on this. I still have a question, namely, what, in your opinion, is the most critical area of application where we up to now do not see an alternative for PFAS? Or would you say, in 10 years' time or something like that, there will be no such areas anymore?
I don't know. For now, probably aggressive chemistry, high pressure, aggressive chemicals where we need O-rings and sealants and tubes that withstand the aggressive conditions. That's certainly something where it is not easy to find alternatives. I don't know what may happen in 10 years. If we look back 15 years, there was not a single electric car on a road in Europe 15 years ago. So in 15 years, a lot of things may happen and will be feasible, or hopefully will be done by innovation.
Maybe it's aerospace.
Aerospace.
Aerospace, yes. The sector which is facing the most of difficulties to replace people.
Thank you.
Other questions?
Yeah,
Sarah.
thanks for that excellent presentation. I think the thing that I often think about is you mentioned at the end there about how do you capture chronic effects in the regulatory process? Do you have any thoughts on what types of data would be most useful to help regulators think about those effects and anticipate those effects in a way that can capture that in that process?
Yes, I think a very important, may call it a milestone even, is HBM for EU, the Human Biomonitoring for Europe project, which was really changed the picture because we learned a lot about the actual presence of chemicals in the human body, and that is so important to see. So just to see what part of the population is exposed at what level, that is the first important point. What's also the spatial distribution of this, and what are the time trends? Is it getting better or is it getting worse? And so human biomonitoring is key. Now that we are in that situation, of course, ideally we wouldn't have that situation, but now that we have it, we at least need to make it transparent and learn what's the matter.
There are no urgent questions right now. Also, in view of the time, I propose that we continue. Thank you very much, Martin. With a presentation by Roxana Kana, who is a legal consultant with Steptoe, and who will talk about legal considerations for the health sector. So it's a somewhat different perspective. Roxana, please go.
Thank you very much, Floris, and thank you to Mr. Tsiodras and to you, Mr. Vasiliokos, for hosting us. Thank you to EU CAMS as well for inviting me. Maybe I would start with saying I am probably the only one in the round table who is not a chemist. So I'm happy to take questions, but not on chemistry. But Floris has kindly asked me to talk about the legal considerations related to the healthcare sector. And I have to start by saying that the proposal, as it was presented in 2023, already at that time presented some features or attributes which made it unprecedented from a legal perspective in the context of the current REACH regulation. The first aspect is the scope, the fact that chemicals are grouped by reference to a certain chemical composition and not necessarily taken one by one, as Mrs. Piraki has mentioned that chemicals have been restricted before. So that's one of the ways in which the proposal is unprecedented. The second one is that the dossier submitters acknowledge the group contains substances which are not hazardous. It is an acknowledgement that not all PFAS in the group are hazardous. Nevertheless, they are included in the scope of the proposal. And the third element which makes it unprecedented is the application of a maybe more of a policy choice that emissions are a proxy for risk. And there are many legal commentators and many legal questions whether this type of approach fits within the current REACH legislation, which mandates a risk assessment. So it raises discussions whether it fits in the context of the current REACH restrictions, but also discussions on who is competent to adopt this measure. Is it the Commission, or should it be rather a policy measure by the European Parliament and the Council? We know that in the context of the Commission comitology process, the Parliament does have a role. It is very limited, it's different from a legislative process. And those questions, I think, will come up in the discussion when you get the proposal from the European Commission. Since the adoption in 2023 of the proposal, we have had some developments, and in particular, we have had the adoption of the updated background document by the 5 core member states, and Norway in 2025, which can be seen as an amended Annex 15 dossier. Again, from a legal perspective, the proposal starts with an Annex 15 dossier, it goes to public consultation, and 2 years from the initial public consultation, we have had an almost new Annex 15 dossier, which was not subject to a new public consultation. That, from a legal perspective, raises a question procedurally: is the measure vitiated by the absence of a new public consultation on a new Annex 15 dossier? And I think maybe fifthly, if I know, lawyers have the the habit of going first, second, third. And fifthly, the upcoming consultation on the draft SEAC opinion that Mrs. Spiraki talked about, and we wait for the draft at the end of next week, has a very, again, unprecedented and limited way in which companies can submit comments. It's not going to be a free text for comments, but it's going to be very scripted, and that again raises legal questions. Why should it be scripted? So now, this is the general legal landscape for the proposal for the healthcare sector, because Clarissa has asked me to address specifically the healthcare sector. The initial proposal in 2023 contained one of the few exemptions from the scope of the proposal applicable to active pharmaceutical ingredients called API. API is in the industry and in the legislation. It didn't contain any other blanket exemptions for the healthcare sector. Comments submitted by many either industry associations or medical companies or medical devices companies in 2023 pointed to the relatively heavy regulatory framework of medicinal products and medical devices, and asked or requested an assessment of whether all elements in a pharmaceutical product, so not only the active ingredient but also excipients and co-formulators, and all medical devices should benefit from such a blanket exemption as well. So again, the difference between an exemption and a derogation is that an exemption is not limited and does not depend on the existence of alternatives, while all other derogations are time limited and depend on the existence of alternatives. And in the updated background document of 2025, we do see that the 4 member states, we'll see the agency, but the 4 member states and Norway, the dossier submitters, have considered the comments by the industry, but have continued to look at it in what I would call a piecemeal approach, specific application, and not necessarily as a sector. So we still don't have an exemption which would be justified by the heavy regulatory and legal framework of medicinal products and medical devices, but rather medical device and medical device. Are there alternatives? How far away are they? Should we go for a 5-year derogation or a 12-year derogation? Which, again, from a legal perspective, raises questions of legal certainty. How much can the industry depend and count on those 5 years or 12 years? And what happens when there is evidence of continual lack of alternatives? Because in Mr. Scheringer's presentation, I haven't seen, again, I'm not a scientist, but I haven't seen medical devices or pharmaceuticals as being some of the sectors for which there are readily available alternatives. So again, from a legal perspective and legal certainty perspective, the industry might benefit from a discussion of a sectorial exemption rather than a piece by piece and mere piece exemption. And that's all I wanted to make as a contribution. Thank you.
Okay, thank you very much. Yeah, so different perspective, also somewhat different cases, I would say. Are there any questions or remarks? Yeah, Stephanie.
Thanks. Perhaps you know this, or maybe Maria, I just can't remember, for the sectors that get an exemption, or sorry, not an exemption, if you get a time limited derogation, is it possible for that derogation to be extended? Like if they get to the end of the 5 years, can they do another 5 years?
From a legal perspective, yes, it would be the same process as the process which led to the adoption of the measure. In practice, there would have to be a proposal from a member state, so there is no possibility for the industry to request an extension of that exemption, and it would have to go through the same process. And we are not convinced, and I don't think there is an answer whether the Commission can actually adopt new amendments for specific parts of the exemption, or they would have to look at all of it together, right? Because again, from a legal perspective, we are going to have an entry of PFAS on one side of the column, on the left-hand side, and then a very, very, very long right-hand column of exemptions. And we have never had a measure where the Commission would only pick on some of those exemptions for review at the later stage.
No other questions? Then I think we should move on. Thank you very much. To the next lecture. That is a lecture in which the industrial perspective is presented by Dr. Takayuki Nakamura, who speaks on behalf of the Fluoropolymers Product Group of Plastics Europe.
Thank you very much for that. And good afternoon, everyone, and Mr. Agostino, and I'm going to miss the Dr. I can also have a difficulty pronounce the Western name, but Theodoras. But and also I'm going to miss him because I have the purpose to meet him today. So then the fellow panelists and the guests. And my name is Takayuki Nakamura. I've been spending most 40 years in the industry, chemical industry, with the background in polymer science and also PhD in organic fluorine chemistry. Today I present fluoropolymer product groups, FPG of Plastic Europe. And then we are now today to discuss the sustainable future, a goal that the fluoropolymers product group shares. To achieve this future, we must look beyond the broad label of PFAS and focus on distinct value of fluoropolymers. These materials are not just useful, they are actually high-performance enablers of the technologies European needs to become sustainable. And from the, for example, from the seal, the hydrogen engine that drives green mobility, to the also ultra pure piping useful for semiconductors or public utilities. Then we also then today is also about demonstrating concrete solutions how our industry strictly manage and reduce emissions during the manufacturing through our newly developed manufacturing program, while we continuing to secure the essential uses of these high-performance inert materials. The path to the sustainable future isn't about the simply removing chemistry. It's about using the right chemistry reasonably or responsibly. Then we believe fluoropolymers are essential to the future. Can you go to the next one? So the FPG presents European lead fluoropolymer producer. You can see the company name up there. I hope you can see the display. I hope it's not too small. Then our message today is simple. We are the voice of the industry that is delivering responsible manufacturing and asking for regulatory clarity. We believe in a solution-oriented approach, and we want to work with the policymakers to design the restriction that is proportionate and effective. We want to move away from defensive argument and toward the partnership with secure critical supply chain while strictly managing environmental risks. Go to the next slide, please. To get the regulation right, we must start with the science. And as chemists, we know that the PFAS is a level of covering thousands of substances. However, science demands differentiation. On this slide, and you see the family tree of PFAS there. I'm sure it's very similar to the definition of OECD. One of the left are on the right-hand side is one of the left and the non-polymers. They are often low molecular weight substances, some of them which are mobile and bioaccumulative. On the other hand, right side of the you can see the fluoropolymer there. It's colored with blue. And there are distinct class. They are high molecular weight, polymers. Why does this matter? Because their large molecular size makes them generally inert. They are too large to cross the membrane, meaning they do not bioaccumulate in the human body. Lumping in inert fluoropolymers with the reactive non-polymers undermine the scientific barriers of reach. And then we must also distinguish between fluoromonomers and fluoropolymers. Fluoromonomers are used as a building block to produce fluoropolymers. But I have to stress that the fluoromonomers emissions are strictly controlled by the companies producing polymers in the oil. Can you go to this slide? Why do we use these materials? It's not for convenience. It's for critical performance. Fluoropolymers are durable, heat resistant, and chemically resistant. They are the hidden heroes enabling the technology Europe needs to meet its policy ambitions. For example, as we just introduced here, renewable energy, hydrogen production and batteries, electronics, mainly chiefly semiconductors or some other electric device that you are using everyday life. Then the healthcare, in the life-saving medical devices, public utility, like a water purification, and also purification of air of the power stations. Then chemical industries are protection of the reactors. They are usually made of metal to just make the reactor is longer life, including light and lining in the ceilings, and also transport. Maybe I don't have to mention that the fuel line, hoses, or ceilings. But if we ban these materials based on the group definition rather than we risk regrettable substitution. Replacing durable materials with alternative that breaks down faster or have a higher carbon footprint. Our goal is to minimize risk while preserving this societal benefit. Can you go to the next slide? So we acknowledge there are valid concerns regarding emissions during the manufacturing phase. We are not waiting for the regulations to fix it. We are now acting now. So this is the you can see the right-hand side, very small, but this information is publicly available on our FPG website. This is the FPG manufacturing program. The program consists of 3 pillars. You can see the left-hand side. One is reduction of emission, reduction of non-PFAS emission covered by the manufacturing program. Second is technology exchange platform, sharing the best available technologies with the industry and also key stakeholders. 3 is guidance for the handling fluoropolymers safely. And then these are 3 pillars for the manufacturing program that the FPG is actually working on. And let me just say a little more about manufacturing program regarding emission control. We have set strict targets. We aim for the average emission factor 0.009% to air and 0.001% to water by the end of 2024, which successfully achieved. Then also we are driving down this down to 0.003 air and 0.006 to water by the end of 2030. This program proved that the fluoropolymer production can be critical, controlled, and low emissions. By enforcing this control of the factory level, we solved the environmental problem without banning the essential uses. With regard to technology exchange platform, the FPG is working on collecting BAT, best available technology information, for reducing PFAS emission. Then that will be again shared with the industry as well as the key stakeholders. For Safe Handling Guide, FPG was actually published version 1 last year, but we are now working on the updating information as a version 2, which probably will be published the second half of 2026. Go to next slide. Then our responsibility extends beyond the factory gate. We are actively assessing the end-of-life management of our product. We are filling the data gap on incineration and recycling to ensure these materials can be handled safely within the circular economy. We are also realistic about alternative. We are also conducting assessment to see where substitution is technically and economically feasible. However, in many high-tech applications, fluoropolymers are currently irreplaceable. Recognizing the essentiality allows us to focus our resources on eliminating non-essential uses while protecting the applications that keep our society running safely. Can you go to the next slide, please? In conclusion, well, a good outcome for Europe is possible. Then it looks like exempt safe fluoropolymers to protect innovation and the Green Deal in Europe, and strictly regulate the manufacturing process to eliminate emissions as we are doing with our manufacturing program. Third is to follow the science to distinguish between hazard and real-world risk. The industry is ready to provide the data and the cooperation needed to make this happen. Thank you very much for your attention.
Some urgent questions. Maybe let me start off. Could you say a little bit more about this technology exchange platform? Is that a platform that's...
Yes, we are now collecting information among the member companies, for example, water, how we can reduce PFAS from water, wastewater side, particularly our side, production side, because you are aware that most contaminated area, I don't know whether it's true or not, but this is what we are told. So then we are working on the water emission as well as the air. And also we are now may include the solid waste as well. But I don't have to worry about solid because we really just under the industrial waste management program that we really just treat our waste, whatever it comes, it's really nicely, and then we don't have to worry about any waste solid there. So only focus on water and the air emission. That could be applied to our downstream users. And also some area that we actually just suffering the contamination of the PFAS in the Europe, and probably just what this group of world as well.
And that's the information that you share within this group of companies that you show.
Yes,
it's not
yes.
outside it.
Oh no, we are also planning to do that as well in the future. Outside, because it's not limited to our industry. Just for whatever, this is our hope, but we still need to internal discussion from the compliance point of view. But it's good if we can share the technology to outside if they are interested.
Yeah.
Thank you very much. I'm just curious because we've known that these substances have been quite harmful for many years. Why have you waited up until now reducing the emissions of PFAS from fluoropolymer production?
Okay, and basically we didn't really start pay attention a long time ago. For example, this is the public information that one company announced that they actually stopped producing. Then that really become fully aware of the situation. Then we started a collaboration with the industry, mainly United States, to discuss how we can actually face this issue, working with EPA. Then they decided to reduce further with the, we call PFOA 2010-2015 PFOA strategy program. then we started really reducing the PFAS emission from our site. This is the situation. So then, but before that, in 2000, we were all complied. Well, complied with the local regulatory issues because nobody paid attention to PFAS. This is the situation.
Sorry for all my questions. This is a big area of my work, so very interesting. Are you working to do anything about unintentional PFOA emissions? I think, as you just mentioned, obviously PFOA was phased out about 15 years ago in the vast majority of cases, but a recent study of a site in the UK, the AGC plant in Lancashire, found that despite not using PFOA, some of the byproducts that were coming out in their emissions still contained some PFOA. So just wondering if you guys are looking at how to monitor that inadvertent emissions and how to still address those.
Yes, and I cannot tell you from the let's say other companies' perspective, but each company has different facility production sites in Europe, usually UK. So then I'm sure that each company or member company, our producers, and aware that what kind of PFAS they use, and also what kind of PFAS might be generated unintentionally during the process. So we are actually here to cover every single PFAS if possible. But some of them it's not easy to capture, I have to admit. But we try to really just reduce emission as much as possible, intentionally or used or unintentionally generated. Thank you.
Urgent questions? Not leave it here for now, and we'll get back in the discussion later on. But first, I would like to move on to the next speaker, Emil Dangaard Muller, who is a senior consultant at the Danish Technological Institute in
Thank you very much. Yeah, my name is Emil. I have a background as a PhD in materials chemistry. I'm working as a chemical consultant at DTI, and then I've been working mainly around fluoropolymer substitution for the past 3 years, working one-to-one with commercial companies. I'm also the spearhead of the Danish EPA initiative called the PFAS Partnership with the industry, where we currently have more than 60 companies, including some of Denmark's largest corporations, with a shared goal of phasing out PFAS in their products. I will start out by saying that I do believe that there are examples where we cannot do without PFAS. Uranium enrichment, for example. I don't believe we can find an alternative for PFAS in that area. But what I'm going to show you today is that there is solutions in most cases. And what we're actually missing is a clear overview of the data. So where is PFAS used and where is it not used? I'll get to that in the end of my presentation, but I'll get there by challenging some of the 3 most common narratives around the PFAS that you see on the screen here and that we have also luckily heard already several times today. Next slide, please. The first claim is that European innovation will stop if we ban PFAS. Next slide. We've banned substances before. We have banned lead. We have banned perchlorinated bisphenols. We have banned asbestos. And perchlorinated bisphenols are a group of chemicals, so it's not unprecedented that we have seen a ban on a group of chemicals. Asbestos is completely harmless when it's in use. What's dangerous is the production and the installation of asbestos-containing materials. Especially PCBs are very close to PFAS by being a class, but also that they have been used in a wide variety of range of products. All of them faced the same argumentations that we're hearing today. They are miracle materials, we'll lose jobs, there are no alternatives to these materials, but they were banned anyways. Next slide, please. Another example is the Danish grocery chain called Coop. They were phasing out PFAS many years ago from their own products, but there was one product missing. That was the popcorn bags. they were told by their suppliers that there is absolutely no alternative viable, cannot be developed. So what did they do? They removed it from the shelves. 6 months after, their suppliers came back to them with a PFAS-free solution. That is basically the initiative right here, why there is almost no PFAS in popcorn bags in Europe anymore. Next, please. All of these substances would still be used everywhere without regulations, and they are still used quite widely outside of Europe, maybe except from that. So I want to ask some questions here. Have we become uncompetitive? Have we lost innovation power? Or did these regulations drive innovation and protect public health? Next slide, please. The next narrative I want to challenge is that PFAS is only used when it's absolutely necessary, because PFAS is incredibly expensive materials. Next slide. Next, not previous. Thank you. So here I want to highlight Marshall that has been phasing out PFAS in their products for many years now. All of the applications over to the left has been applications where they have rather easily been able to find non-PFAS and non-fluoropolymer-based materials. The few examples on the right are where they are currently in development with their suppliers trying to find alternatives. Next slide. Another case is Micromatic. A Danish company is producing tapping equipment for the entire world. They have always used Viton O-rings for their equipment simply because they were told it is the best. They wanted the best, so they chose that. Now, some of their customers required that they tried to phase out PFAS, so they chose another gasket, HNBR, that was working equally well. So that is what they're using now. Next slide, please. If we say that PFAS is only used when absolutely necessary, we can draw some conclusions from that. That means that every company has material experts making optimal choices. It means that every material decision is carefully evaluated. It means that there are not materials even more expensive than PFAS that could have a similar performance. And it means that companies would always value a small saving over the security of materials that we have used widely for the past 80 years, and we have a long track record of knowing to work. Anybody who has worked in product development knows that these claims are false. Next slide, please. The third narrative is that our products will suffer because PFAS are miracle substances. Next slide. Remember that this is the same narrative that was given for lead, asbestos, PCBs, and I want to give 3 very concrete examples where I can showcase that this is not true. The first one is ceramic speed bearings. Next slide. They have always used PTFE in their bearings because it has the lowest friction, so why not use it? But they started actually investigating, could they find a replacement? They found a replacement that had 30% lower friction and a longer lifetime, because they understood the function that PFAS was having. Next slide, please. Another example is a collaboration we had with a company that was looking for a gasket for dry dynamic applications, so as a seal that has to go back and forth without any lubrication. Now, they were choosing PTFE because they wanted it to last as long time as possible. But PTFE is actually not a very good material for wear resistance. So we were quite easily able to find a good alternative there that gave longer lifetime of the product, saving the company money. Next, please. The last one I want to highlight is artificial veins, which is predominantly used with PTFE today because it's inert and we have to have it in our body for a long time, right? But that inertness actually creates complications in 70% of all operations. And right now there are PFAS-free alternatives emerging that are mimicking the properties of our actual natural veins instead of just being inert. So all of these cases, we see an actual improvement of performance. Next slide, please. This brings me to the conclusion that fluoropolymers are do-it-all materials. They are basically the Swiss Army knife of polymers. Next, please. And saying that there are no good alternatives to PFAS means that there are no materials that are as versatile as PFAS. I believe that is true. There are no material that is as versatile as PFAS. But if you're cutting vegetables in the kitchen, next slide please, you're probably better off using an actual kitchen knife. Right? Saying that the kitchen knife is not able to open a bottle of wine doesn't make it a bad alternative for cutting vegetables. And this is what we're seeing over and over again in our work, that when we actually look at the application where we need to use the material, we can find something that is even better suited than fluorocarbon. Next slide. This brings me to my final conclusion, that I truly believe that we lack a clear overview of available data. And that makes it very easy to overcomplicate the story. I know all of these examples that I just mentioned because it's my daily work, it's what I do. But that knowledge is not readily available to the public. Next slide, please. If we take medical devices that we have talked a couple of times about today as well, there is this narrative, for an example, around implantable devices. Fluoropolymers are predominant in implantable devices. Other materials have a high risk of complications post-operations, and we risk lives if we remove the availability of fluoropolymers in this application. Given that information, the decision should be very clear, right? We should maybe not ban PFAS in these use cases. Next slide, please. But if we actually look into the data and do a fact check of these claims, we can see that 80% of all hernia meshes used today is made from polypropylene and polyester, which are non-PFAS materials. Now, this exact case is very easy to verify on Google, but we are talking PFAS applications across tens of thousands of different applications, and we cannot do this kind of fact check for every single material. But that is what I'm working on providing right now. Next slide. So for an example, for hernia meshes, we are scraping all available information that are available. For hernia meshes alone, we have found 1,600 articles, and we have found over 3,000 patents that we are data scraping using AI, structuring it in a good fashion, so that we have the complete overview of where hernia meshes are used and what are the possible alternatives to really give good information. And we are automating this to do more than 10,000 PFAS applications. And hopefully this kind of data will both make it easier for the companies in their substitution processes, so they can actually get a feeling of what can they do in specific cases, but it will also make it better for the legislation makers to make science-based decisions. Next slide. With that, I want to end my talk and say, please don't underestimate what scientists and engineers are capable of. Look at our development the past 10 or 30 years. It's been absolutely incredible. If you believe that taking away one material class from our portfolio of materials that we are allowed to use, and believe that we are not able to make front-runner product, and we are not able to make airplanes that don't fall down from the sky, you're mistaken. It is basically like a child saying to me, it's impossible to run a marathon. It might seem impossible to the child, but I've run a marathon, so I know better. Thank you very much.
Thank you very much, Mimi, for this point of view, which is again different from the others, and I think it's very good to see a mix of very different viewpoints in this meeting. Questions or remarks? So maybe one to start off, Emil. So you mentioned the enrichment of uranium as one where PFAS cannot be replaced. you're very optimistic about PFAS replacement, obviously. But then I think also I guess there's low-hanging fruit, and PFAS that can be easily replaced. PFAS where the scope is much longer. So how could you make predictions on forward? So what that's maybe a good question for the discussion later on. And so how extensive is the search for a PFAS alternative? Would that differ from application to application? Could you say something in general about it?
Hopefully very easy in half a year's time when we have that data that I talked about available. And that is pretty much the main issue here, right? It's the size of the problem. We are collaborating with a large Danish company that has more than 20,000 components containing PFAS. They're trying to figure out how to phase out PFAS in those products. It's not because it's scientifically impossible. It's just because the amount of work that is needed is completely incomprehensible.
Any other remarks or questions?
Thank you for the presentation. I was actually the AD on the study that was mentioned and presented last week about the PFAS. So I was listening to the presentation and two questions came to my mind, because how you're presenting it is very application specific. So let's look at the application. Can we replace? Can we not replace? And I was wondering, what would your approach be to, let's say, a sector like semiconductor, where the entire manufacturing is PFAS dependent? And then another question would be, how would you look at the energy defense sector, where, for example, a lot of these data is not available and cannot be made available?
It's a good question. It takes a lot of scientists to do that. That is the difficult part, right? For the defense sector, there is still a lot of patents out there on specific components for specific defense applications, for an example. So it might be one of those sectors where it's a little more scarce with data, but hopefully it can benefit from data from applications that are similar to those used in the defense sector. And then, apologies, I forgot what was the first
about the whole process, let's say, of semiconductor manufacturing.
Oh yeah.
PFAS dependent.
Yes. I believe it's the same for the production processes, that we are able to find good alternative. I know that there is a semiconductor manufacturer. It was the Danish EPA that told me this, so I don't have the specific reference, but I can find it to you. But there is a semiconductor manufacturer that has successfully made semiconductors without use of any PFAS processing aids. So I think for that specific application, there should definitely be a way forward.
Yeah.
Just to add to this, we are in contact with IBM and Apple exactly on this, and they are doing a life cycle approach and trying to find out where they use PFAS in their entire production chain and system. So they are working on that.
Yeah.
Even on the processes that cannot, like, for example, there are the technology and processes that are specific to Taiwan and China that we don't have access to, like how do we then get about that? Because then the story gets very complicated, I would guess.
That is, luckily for me, not my headache, but the legislation makers, I guess. But it's going to be very difficult, and we can only get there by demands, right? If they are told that the entire European market will not buy from them, taking the popcorn bags off the shelves, right? They'll have to do something, but it's also a huge risk for Europe if we were to do so. So hopefully we can find a way forward in between those two cases.
Yeah, I think that's maybe also a good point to move on to the next speaker, who will speak on behalf of the European Commission. Dennis Martin.
Good afternoon, everybody, and thank you for inviting me. A lot has been said already, but I will just give some overview of the policy initiative regarding PFAS. I'm Denis Martin, working at the European Commission, DG Grow. I'm a chemical engineer by background. So, yes, so next slide, please. So yes, it has been said already, but still have to stress that we have to deal with different challenges in addressing the PFAS pollution. So on the one hand, we have serious human health and environmental concerns, but on the other hand, we have the fact that PFAS are used in critical applications, which are needed for the twin transition, for example, for the green and digital economy, but also strategic economy. So we need a balanced approach, balancing these two aspects, and this is really the challenge of all this. So next slide, please. So it has been mentioned by previous speakers already. Regulation of PFAS is not something new. Some of them have been restricted to ban for a long time already. Just some examples here at the international level via the Stockholm Convention, the P4, the PFA, which is the C8 substances, the PFHXS, the C6, newly the PFCA, C21, sorry, which has been agreed at the last Stockholm Convention and which will be soon moving to the EU pop regulation. We have also some REACH restrictions, so the C9, C14 PFCAs, which will soon move then to the POP. We have the TDFAA. We have more recently the PFHXA, C6 entry, and even more recently, an important one for which we have seen the examples in previous presentation, the PFAS in firefighting, for which we have seen also innovation going on with successful alternatives going on. And this was a key one since it led to quite big emissions in the environment, of course. So this is not, so regulation on PFAS is not something new, and it's going on, as you know. Next slide, please. Beyond REACH and Stockholm Convention and POP, we have also different regulatory measures relating to water, for example. This is also very on the agenda now via the Water Framework Directive, or the Groundwater Directive, and the Environmental Quality Standards Directive, where PFAS are proposed to be on the list of priority substances for surface water and to the list of pollutants in groundwater, and to limit these pollutants. Also, for the Drinking Water Directive, there are new rules from this year where there are harmonized ways for member states to monitor PFAS in drinking water, and a duty for member states to take actions and to reduce the levels and to protect human health, and also to inform the public. Also, as regard to food packaging, food contact packaging, then there are new rules also coming this year that this packaging should not contain PFAS above certain limits. In toys as well, there has been new measures where intentional PFAS in toys will be banned even from 1st of January this year. So as you see, there are many regulatory measures still ongoing. Next slide, please. And of course, we have the so-called universal PFAS restriction that we talked about, and I will give a few updates on that one, even though already my predecessors already mentioned some of those, but I will nevertheless recap some of those. Next slide, please. So this is a huge dossier, as you know, prepared by 5 national treaties. Now it's still under the opinion-making process at the European Chemicals Agency. We just had the adoption of the opinion from the Risk Assessment Committee. SEAC is due to is forcing to adopt their draft opinion next week, indeed. And then by the end of the year, we hope to get the final opinion from it, and then we'll start the Commission proposal phase, which will be debated in the REACH committee with member states, as you know. So next slide, please. So we are still in this long process of opinion-making, decision-making afterwards. I just mentioned that. So the RAC opinion has been just adopted. It will be published in the coming weeks. The SAC will be adopted normally next week, and soon afterwards, the public consultation on the draft opinion will start for 60 days. Just to remind that the consultation is about the SEAC opinion. It's not about the RAC or the RAC aspects. So it's really about the socionic aspects, the availability of alternatives, and the opinion itself, right? So this is important to frame that again. And we really invite all stakeholders to provide comments to that. This is, I think, this is really a key consultation because there are so many uses, so many applications. It's so complex for everyone. It's really important to have latest information because since the previous consultation in 23, things have evolved as well and so on. So now people can see the actual opinion, the draft opinion, and they can comment on those. So this is really key. Even though we are all well aware that okay, there are limitations in the format of the consultation. But this was decision for MECA to allow a quicker absorption of the comments and the delivery of the opinion because there is a willingness to progress quite quickly with this decision proposal. So as I said, the final opinion is expected end of this year, and then the Commission is intending to go as fast as possible with proposing a solution. So next slide, please. I'd like to mention also to frame a bit this resolution proposal in the overall context of the policy objective of the Chemical Industry Action Plan, which was published in July last year. And this clarifies quite a number of important elements. And as regards this PFAS restriction, a number of important points were highlighted. So first of all, I just mentioned that the Commission is committed to presenting a proposal as soon as possible once we receive the final opinion from ECHA, with the overall objective of minimizing the PFAS emissions. So this is the first point. The Commission will consider a ban of consumer uses, such as cosmetics, contact materials, and other clothing. These are examples. This is more for consumers, and in terms of industrial applications, where alternatives are not available, and the continued use of PFAS for critical industrial applications would be allowed under field conditions until acceptable substitutes are found. Also, derogation for uses will need to be accompanied by requirements to reduce emissions at all life cycle stages, to reduce the release of pollutants, and by clear incentives for substitutions, incentives to innovate. So all these elements are very important to this frames a bit how the restriction should normally look like. So we'll work on that basis. So next slide, please. But the Chemical Industry Action Plan does not talk only about the universal PFAS restriction. They describe also other initiatives, important initiatives, to move towards this replacement of PFAS and minimization of pollution. So one of them is the stakeholders dialogue, which will be launched soon, where exactly the aim is really to bring all kind of stakeholders to discuss about how to push the next exchange information and so on. We discussed previously about the importance of research and innovation, and this is something that the Commission wants to have an action. So Commission will support targeted research and innovation funding, the build of expert networks, for example, via these innovation and substitution hubs that we are starting to put together, among other things for PFAS. There is an action which is foreseen also to clean up polluted sites based on the principle of the polluter space principle. But also public money would be made available for orphan sites where the originator of the pollution cannot be found. And there will be also research and innovation funding for remediation. Also, an important initiative which is foreseen is the private-public partnership for PFAS detection and remediation, to the extent partners are found willing to embark in this partnership. And then quite important aspect as well is the EU-wide PFAS monitoring framework, which is set to centralize information on polluted sites, remediation techniques, and gather data from various legislation. So as you can see, there is a broad scope of policy measures, initiatives, and this is not an exhaustive list. There are many also initiatives beyond the EU level, of course. At EU member states level, there was a lot of initiatives as well. Industry itself is organizing themselves in various initiatives. We've heard some examples earlier today. So there are many things out there, and it's important that everybody is aware of the issues, and that the things are moving, and we see, as we have seen, that there is a lot of progress on all sides in terms of search for alternatives, in terms of abatement techniques, remediation techniques. There is a lot going on in terms of analytical techniques to analyze the pollution. So it's a big fight, but it moves a lot of stakeholders as well, and I think personally that it can help also the EU to get stronger on many fronts, in innovation, but also many other fronts. So I think it's also an opportunity to seize for you. So I think this was my last slide, if I'm not mistaken. So thank you for listening.
Okay, thank you very much. That is also clear what the directions are which the Commission is thinking. Are there any questions directly related to this presentation? Yeah.
You said that by Q2 2026 you would have the stakeholder dialogue, which I think is essential. Can you comment on that? How will that work? How will you find the stakeholders, and how will that then be enabled?
So it's actually DG Environment in the lead on that one, so I don't know all the details. Yeah. But the idea is that any kind of stakeholders would be welcome to join. I don't know exactly how they will structure the dialogues. I guess they will have some topics and gather stakeholders based on those. But in principle, it should be open to everyone. And I'm quite sure that you can also raise topics for discussions, I suppose.
Other questions? Then thank you very much. I propose then, also looking at the clock, that we spend the next 10 minutes on a sort of perhaps broader Q&A session, things that you may still wonder after this discussion. So maybe first to kick off a sort of question for me to the speakers. So we closed with the lecture of Emile, which there was a lot of optimism about finding replacements for PFAS. Obviously, this requires a lot of research by industry, research I think also by academics. Dennis mentioned private-public collaborations. So that obviously also involves quite some costs. There are legal aspects associated with changing, of course, from one material to the other, and at the same time there's a competition outside Europe, in the US, in China, elsewhere in the world that will, I would say, work against the costs that we make to find alternatives. After perhaps hearing the optimistic talk of Emile, could I have some comments from the other speakers, perhaps? Maybe a legal thought or the viewpoint from industry, or Martin? Do you share this optimism?
Oh, I do not share or share. In fact, I have I don't have the information to necessarily contradict or agree. But what I would say is that they are very indeed application specific and case specific, and maybe a reminder that legislation doesn't prevent the replacement of PFAS already today, so I think that's definitely to be encouraged. One aspect which maybe was not as present was how would the alternatives be accepted and approved under different types of sectoral legislation. Again, looking at medical devices and the pharma legislation, there are very long processes, quite cumbersome, and those are not necessarily taken into account when regulators talk about timelines of prohibition. Maybe that would be my comment. I cannot comment on specific applications, but more generally, also in the spirit of simplification, which is the word of the year, maybe, and of the decade, the fact that other types of regulatory approvals and other types of systems already exist and impose quite cumbersome obligations on the industry should be considered in as a factor for the current proposal for the ban. And it doesn't seem to be in a very systematic way. It's taken into account that there are comments to that effect, but it's not a recognition that this is a systematic consideration for the proposal.
Yes, in response to Emil, I would say, well, of course, we may call this optimistic, but what I really like to have an important about presentation is this is our real. So it's not kind of optimistic kind of perspectives, but these are cases that you investigated, where you found already what's there. And I think that is very important to see that there are really, there's evidence that things can be done in a different way. And remarkably, the last example where the performance was higher than the performance with the PFAS solution. That I think is also remarkable. So it's not just costs, it's also gains that we can expect to some extent. And another thought is that I really find it very important what Emil said about it has to be case specific. And we learn a lot from these cases. So we also we are also looking into many cases. And one case is in wind turbines, and we asked the wind turbine makers about the coating of the blades, and we learned they don't use PTFE or other fluoropolymers to coat the blades. Actually, people say they are coated with PTFE fluoropolymers, but they are not. So there are also uses that don't even exist, but people may think they do exist because it would make sense. Of course, it would make sense to use PTFE or other fluoropolymers, but they are not. So I think it's important to look into these cases and learn about the specifics.
Yeah, so don't get me wrong. I'm actually very happy with the statement that everything can be replaced, and I also like the comparison with the Swiss Army knife very much, I must say. Yeah. And so maybe first the industrial.
Oh, thank you very much.
Thank you.
Up two things. One is regarding the patent things. But when I was working for the company more than 40 years, I know what reason why we filed a patent. Because if we discover very good ones, new technology, then why not? Because we don't want other companies to really take advantage of it. But also, it's very important to file a patent because other companies actually file the same patent, so to make it available. So the patent numbers are not necessarily to show that technology is available. So this is a very important point. But having said that, I acknowledge that you were working on the 1,600, you said, the different applications.
Oh, more than 10,000.
10,000. But I cannot speak on behalf of our customers. But I'm sure there are more than 10,000, 20,000 applications that are available. Even you talk about fluoropolymers. And then then one application, whatever candidate, may not be applicable to others. So this is a very complex point that when you just talk about the alternative development. And I talked to lot about this case with the automobile industry. They kept telling Tucker, I don't want to use fluoropolymers because they're expensive compared to others. Of course, some of them are more expensive than others. But it's now because of the effort to reduce cost and the polymer prices are decreasing. But having said that, still more expensive than auto fluoropolymer or other materials, but they have no choice but using it. And then automobiles, semiconductors, and medicals and healthcare, they have been using fluoropolymers almost 30, 40, 50 years. Then why they have not found any alternative? Because of probably PFAS restriction. This is one of the big things. But also they cannot find any alternative. So this is also we have to realize that. So some of the application may be replaced by non-PFAS or whatever polymers, others, but some of them not. This is what we think. That's why we are working on reducing emissions as much as possible to make fluoropolymer available in the future for the society.
I saw my view.
Yes, thank you.
It's that he doesn't necessarily agree.
First of all, I don't think companies will move away from PFAS if there's no legislation. We've seen that with some of the legacy chemicals that we have already banned, right? They're still used widely outside of Europe. And why would you change your product if you know it works, right? No sane company would do that. Every single company I've worked with on PFAS substitution has been because of the fear of a potential ban, and they want to be on the forefront of that. Nobody are doing this out of their free will. Second of all, 99% of the companies I'm talking with have never even considered looking for alternatives. So I don't buy the narrative that fluoropolymers are only used when absolutely necessary, because they are not that expensive, maybe with exceptions from FFKM, which are incredibly expensive. But PTFE is not that expensive compared to the security you get of using that in your products. Thank you.
A few questions first, Hans-Georg.
Thank you very much for the interesting talks. From environmental chemists in the German Chemical Society, I learned that probably the most problematic PFAS is the smallest molecule, trifluoroacetic acid, because it's water soluble and comes from decomposition from the larger ones. Can you comment on this, how this will tackle us, the planet, organisms, mankind?
Any opinion on PFA?
Complicated. What we know, what we can say is there are large amounts. That is the biggest concern. The concentrations of TFA in various media have been increasing even exponentially over the last 5-10 years and more. So that's just a question of really amount and concentration, much higher than the other PFAS in water, for example. And there are also increasing concerns about possible health effects. The health effects are not yet fully established, so we know the most about P4 and PFOS. These are the ones that have been investigated in much detail, and the health effects are really well not understood but documented. PFA is a different situation, but just because the fact that the amounts are so big and concentrations are increasing so rapidly, that is of course a concern, because again it's irreversible. It doesn't degrade, it will never go away.
Any more comments? If not, then Stephanie.
Thanks. I probably could sit here and talk about all these things for about 5 hours, but one thing I've been thinking about, maybe to see if how you guys have encountered this, is as with many things, China is doing more of everything than we are. They're producing and using more PFAS, but they're also producing and using more PFAS alternatives. I take the point very, very well that patents don't necessarily mean that something exists or is usable yet, but China has been having the highest numbers of in the last few years of PFAS alternative patents, in addition to, again, their uses of PFAS. So how do we, as Europe, wanting to stay competitive and, again, potentially being the foremost market for PFAS alternatives very shortly, how are we going to make sure that innovation is happening here and that we are driving the market for alternatives and able to take advantage of that opportunity, as opposed to, again, like many other things, ending up with having to source all of our new materials from China, who seem to have gotten quite a jump start on this.
Well, I think that, and I would like to speak for my experience in my previous life, legislation is the locomotive for this. And that's why it's very, very important, and I would like just to repeat the call from my colleague from the Commission, that you have to participate in the consultation of SEER in ECA. It is the committee, the socio-economic impact examining. And of course, it is very, very important to participate in the public consultation when the Commission drafts the first legislation of restriction. Because since we have a EU-wide legislation, particularly a kind of regulation, I think that the Commission will prepare something like this in order to have a streamlined approach when it comes to the EU and to the industry needs. I think that this is a very, very significant step forward. We cannot face the issue in terms of competition, because China is also using the most difficult and dangerous and very, very heavy chemicals in the world. So we can proceed with our approach. And our approach is protecting people and the environment, facilitate innovation, and giving to the people and to the industry a predictable legislation in order to go on.
So, Clarissa, if I may, I would like to comment. I think it's a really interesting point, in fact. And so I would say that again, from a legal perspective, the Commission is obliged to take all comments into account and to assess all alternatives. So there has been already a case before the European Court of Justice in which the Commission was criticizing for not having assessed all informational alternatives. Now, assuming that the informational alternatives is provided during the public consultation, assuming that that information refers to alternatives which may not yet be available in Europe, I would say that maybe then that's an assessment of how available the technology would be. So maybe that's one way to tackle it, is whether there would be supply chain restraints, right, export restrictions, supply chain disruption, and would make that potential alternative less available by the Commission.
Okay, thank you. I'm looking at the clock, and I think we have to stop this interesting discussion. I promised that we would provide you with different viewpoints, which we have seen. I think also constructive discussions. So I hope that this process, that these discussions were informative and useful for working on legislation, working on policy. And having said that, I thank you all very much for participating, and I would like to give the word to you again to close this workshop.
Thank you very much. First of all, I would like to thank you very much, all the speakers, for their time and contribution to this very important and timely discussion about PFAS. And of course, we would also like to thank you very much the other for your participation in this event. It's very important to listen all the different perspectives, and that's what we're trying to do here in view of ahead of the preparation of policy, ahead of the policy making. Maria highlighted a very from her experience, a very important point, that you should participate in the consultations by the Commission, because your opinion, your contribution is very important, and the Commission should take it into account. And it comes to my intervention that I mentioned, I highlighted that here we need a partnership with the stakeholders in order to draw a reliable policy. But this partnership should be based on reliable and credible scientific evidence. What we ask from you, what we ask from the stakeholders every day, come to us, engage in our policy making, but you should provide us concrete and credible scientific evidence in order to prepare an effective policy. In closing, I keep some points that were very aligned to this science-based decisions. It's very important. It's very important to trust the scientists to trust the institutions, and after to trust the policymakers that will prepare an effective policy for the European citizens. And of course, every policy should have a balanced approach. A balanced approach between the science and between the competitiveness and the protection of the citizens. And I repeat it again that our first priority is the protection of the European citizens. And we are pretty sure that this can go hand in hand with the protection, with the support of the European competitiveness. And we are here to ensure this balance, and we are here to listen to your voices, and we are here to engage you in this discussion. Having said that, I also thank you very, very much for your contribution and wishing you all the best for
La prego, mi fa parlare.
Your contribution to this discussion.
Messie Dimitri, sono piccoli Michela, una mamma. Sono una mamma italiana.
I'm Italian, perhaps I can translate.
Nel sangue di mia figlia ci sono 86,9 nanogrammi di PFAS in un cucchiaino da caffè.
Just a moment. In the blood of my daughter, there are 86.9 nanograms milliliter of PFAS.
Per noi, madri italiane, madri di tutto il mondo, voi siete il prolungamento, siete coloro che hanno il coraggio di affrontare una situazione così grave.
For us, who are the mothers, Italian mothers, but the mothers of everywhere, you are the person who can have the braveness to afford this kind of problem.
Io non posso fare il vostro lavoro, io sono un'infermiera e curo i malati terminali.
I can't do your job because I am a nursery and obviously I work in an hospice.
Ma voi dovete guardare dentro al vostro cuore e pensare che quello che fate poi si ripercuote sulle vite di ogni famiglia.
But you have to think about what you are doing because everything you will do, everything you will choose, have a relationship, what is going on and will go on the future and the life of our sons and children.
Queste le nostre proposte che facciamo al Parlamento Europeo e le analisi del sangue dei nostri figli.
These are our proposal and the reports of the blood samples, the results of the blood samples of our children.
E vi ringrazio con tutto il cuore.
Thank you very much for having paid attention to me.
Stiamo cercando di fare.
Mille grazie for your contribution. I cannot speak Italian, but thank you very much for your contribution. Be sure, as I mentioned before, that all the voices are listened here. And for your info, I am also very sensitive to these issues because I have also a kid of 3 years old. And I'm strongly interested for life, for your future life. Thanks.
Grazie comunque, stiamo cercando di farlo. We are trying to do it.